We are going to work on solving proportions using a few different strategies. The first one we're going to work with is solving using a direct relationship, meaning that when we're looking at the ratios separately, 2/5 is a ratio, 8 over x is a ratio. A proportion means that we want two equal ratios. So the same part of the total or same part-to-part comparison. So when we look at it, we want to find a direct relationship between the numerators within the ratio so that we can create that same relationship within the denominators. As you see in the first example from 2 to 8, we always use multiplication and division. So to get from 2 to 8, we would need to multiply by 4, because 2 times 4 gives us 8. That's a direct relationship. So we can use that same thing, making this match. So 5 will also need to be multiplied by 4. It's very similar to equivalent fractions, except now it's equivalent ratios. Ratios different from fractions, but we can use them very similarly. 5 times 4 then gives us 20. So we know that our missing value would be x is equal to 20, because we used that same operation. If we look at the second example, this time the number missing is in the first ratio, which is fine. We're still looking for a direct relationship. We're missing one on the top, so we're going to look at the bottom values where they both appear. To get from 7 to 28, we would be going the wrong direction. We want to go from the double filled to the one missing. We're trying to get from 36 to x. So we need to find the relationship from 28 to 7. 28 would need to be divided by 4 to get 7. So that means we would need to do the same thing to the 36. Dividing it by 4, and 36, you can always show it off to the side if you want to. That should be a nice math fact for us, giving us 9. So we know that x is equal to 9, because when we do the same operation, dividing both of these values by 4, we get 28 divided by 4 is 7, and 36 divided by 4 is 9. Creating that direct relationship, going in the same direction, must move in the same direction. That's very important. Okay. Sometimes though, that direct relationship that we've been seeing isn't super obvious from the beginning. So the first thing we need to do is simplify to create that direct relationship. Because a lot of times we can simplify one of the ratios and that direct relationship will be there. Sometimes you have to simplify a couple times, and that's okay. When we look at the 6 and the 21, 6 can be divided by 2 and 3. 21 cannot be divided by 2, but it can be divided by 3. So we're going to divide both of those numbers by 3, hoping to create a direct relationship, because 6 can't directly be multiplied to become exactly 22. So when we simplify that, the 6 is going to become a 2, and the 21 becomes a 7. So now we've replaced the 6 to 21 to be the 2 to 7. So we can rewrite that proportion as 22 over our variable d, that missing value, and we want that to be equivalent to 2 to 7. Now that we've simplified, there is a direct relationship from 2 to 22. We would need to multiply by 11 to get there. So we're going to do 11 times 2, that equals 22. So once again, we're going to do the same operation, moving in the same direction, and we're going to multiply that 7 by 11. 7 times 11 gives us 77. So we know that our missing value is 77. And we simplified first. Let's do that for the next example as well. there is no direct relationship from 6 to 4. Notice how we're going from the one filled in to the one with the missing value, to the variable. 6 to 4, there isn't a nice division problem that'll divide and give us exactly 4. So we're going to simplify first. A 6 and a 9 can both be divided by 3. So we're going to divide both of them by 3. That gives us a 2 in the numerator and a 3 in the denominator. So now our new ratio is 2 to 3 is equivalent to 4 to y. So now we can see that there is a direct relationship from the 2 to the 4. We're multiplying it by 2, so we're going to use that same operation in the same direction to multiply the 3 also by 2. 3 times 2 gives us 6, so we know our missing value is y is equal to 6. This strategy works for larger numbers as well. You'll notice that 25 and the 70 are much, much bigger numbers, so it's hard to tell if there's a direct relationship between these bottom values. So we want to look to see if we can simplify. One ending in a 5, the other ending in a 0, so we know that we can divide them both by 5. Some long division may be helpful. However, the numerator, we will hopefully know, 25 divided by 5 is 5. 70 divided by 5, long division may be more helpful for this one. It's not one that we do as commonly. 5 goes into 7 once, with 2 left over, bringing down the 0, and 5 goes into 24 times exactly. So the bottom is going to be 14, because 70 divided by 5 is 14. So now we have our proportion of z over 42 is equivalent to 5/14. We may want to check what this common one would be. So let's check, well, 10 times 4 would be 40, but this is more than that, so we maybe want to check times 3 instead to see if that would work. So we're going to check 14 times 3, that's going to give us a 12, and then a 4. You'll notice that's exactly what we needed. So we're going to multiply the 14 by 3, meaning we also multiply the 5 times a 3. And 5 times 3 gives us 15. So we know that z, our missing value, was 15 to solve the proportion. So that is solving proportions using a direct relationship. Sometimes that direct relationship isn't immediately visible, so we simplify it first to create the direct relationship, showing our work along the way to find the missing value in the proportion. They should be equivalent, meaning the same operation in the same direction. Then we also have the strategy of using cross products. Cross products is a great strategy when there isn't a visible direct relationship, or simplifying may be a little bit challenging, which happens sometimes, where it's not easy to simplify. That's when we can use cross products. What this looks like is the m right now is being divided by 6. So we're going to multiply in the numerator by 6, and when we do that, we would have to match it on both sides in the numerator. What that really is we're multiplying diagonally to the numerator, and we're going to do that for both of them. So we're going to write it as 6 multiplied by 6 is equal to 9 times m. We're going across diagonally using multiplication and then setting them equal to each other, just like the equal sign is in between the proportion. That's why we call it cross products. Products meaning multiplying. Across meaning diagonal, cross products. Then we're going to simplify this equation. 6 times 6 is 36. And now we have a one-step equation. To cancel out multiplying, we're going to divide by 9. 36 divided by 9 gives us 4. So we know that our missing value is 4. If we try the next one, Using cross products again, cross multiplying. And we're going to set that equation up. So we're going to have 7 times 30 set equal to 12t. If you need to show this multiplication off the side, absolutely do so. Then from there, to cancel a multiplication, we need to divide. So we're going to divide by 12. This is where those division skills that we've been working on will come in handy. Putting the top number in the box, so 210 divided by 12. It doesn't go into the 2, but it does go into 21 once, which gives us 9 left over, and we're going to carry down that 0. You can guess a number to check, so I'm going to check 7 first. It gives us 14, and then 84. We can't get any closer than that, so it's going to be times 7, which gives us 84, so when we subtract, we get 6. Since we were to the end of our number, we add a decimal and a 0, making sure we bring that decimal straight up before we carry the 0 down. Since 84 was much too high, 7 wouldn't work for this one, so maybe we check 5 instead and do 12 times 5, which gives us exactly 60. So it's going to be a 5, which multiplied directly to 60. So we know that 210 divided by 12 is 17.5 for our final answer. Sometimes, before we want to do the cross products, we want to simplify, because the numbers we're working with are quite large, and if we simplify them, the multiplication will be a little bit easier. So that's what we're going to do. We use this strategy when we have really large numbers that if we were to multiply them together, it would give us even bigger numbers, and we don't want to do that sometimes. So when we look at the 25 and the 70, you'll notice that one ends in a 5 and the other ends in a 0, meaning we can divide them both by 5. When we do that, 25 divided by 5 gives us 5. The 70 you may want to show off to the side. Giving us 14. So now we can rewrite that proportion so it's a little bit easier to follow. And then you'll notice that it's much easier and much smaller numbers to work with along the way. We still do cross products, multiplying diagonally. So we're going to have 14z. Notice how the number goes first before the variable. And then 42 times 5. When we simplify, again, always showing that work off to the side. Which gives us 21 is equal to the 14z. Then when we divide by 14, we show that work off to the side as well. So 210 divided by 14. Very similar to what we had before, but not exactly. It doesn't go into the 2 and it goes into the 21 once, with 7 left over. When we bring down that 0, that's when we want to check. So maybe we'll multiply it by 5. It was a good starting point. That gave us 20, which will give us 70, which is exactly what we wanted. So we know that 14 times 5 gives us 70 exactly. So that means 210 divided by 14 is 15. So our missing value in the proportion was 15. 15 to 42 is equivalent to 5/14. One more example of simplifying before using cross products. 21 and 56 are both pretty large numbers, and when we look at 3 times 56, that would get even bigger. So we want to simplify if we can. The 56, 6 plus 5 gives us 11. So we know that 11 is not divisible by 3. So even though we would like to divide the 21 by 3, that wouldn't work. But 21 divided by 3 is 7, and 7 would work because 7 times 8 is equal to 56. So we're going to divide both of these numbers by 7. When doing that, 21 divided by 7 gives us 3. 56 divided by 7 gives us 8. So now we have 3p is equivalent to 3/8. You may notice something similar. However, we're still going to use our cross products just to practice the strategy, multiplying diagonally. So we're going to start with our variable side. 3p is equal to 3 times 8. Again, you may notice similarities, but we'll simplify. 3p is equal to 24. It's a one-step equation at this point. And we get p is equal to 8 as our final answer to create that equivalent fraction. So cross products is another way to solve a proportion. Cross meaning diagonal, products meaning multiplying. So we're multiplying diagonal to set them equal to each other before we solve that equation to find our missing value. Creating a proportion, which means equivalent ratios. Sometimes we have proportions that have a group within them. Grouping meaning that there's a grouping symbol which isn't always shown as parentheses like I just drew. Sometimes it's a fraction bar instead. And the fraction bar is not only showing that it's a division, that it's fraction, but also that it's a grouping symbol. So we have to keep that in mind when we're using cross products. When we see this fraction symbol, it may be helpful to draw that fraction bar or to draw and add in grouping symbols because this means grouping is happening. So when we use cross products, which we can do, multiplying diagonally, this multiplication eventually will need to be distributed to the group. If we start first with just the 10 times 4, we'll set that cross product equal to the other side. 5, and we're going to use those parentheses because this meant a group. So 5 parenthesis m minus 7. Okay, we can simplify what we can. We know that we can multiply 10 times 4, so that's going to give us 40. Set equal to, and we can leave this for now. We can't subtract first within our parentheses because we have an unknown. So to get rid of parentheses, we need to distribute the 5 to both terms, which is going to give us 40 is equal to 5 times m, 5m, minus 7 times 5, which is 35. From here, we want to isolate the variable using SADME. Any addition or subtraction that we want to cancel using inverse or opposite operations. Before we get to any multiplication or division. So we're going to add the 35 to both sides to its like term, which is going to give us 75 equal to 5m. From here, we would need to divide by 5, canceling out the multiplication. And you can always show that operation off to the side. 75 divided by 5. It goes in there once, with 2 left over, bringing down the 5, which goes in there 5 times exactly. So we know 75 divided by 5 is equal to 15. So 15 was our missing value that would make this true. If we wanted to check, we can always plug that back in to simplify. So let's show that. If we plug the 15 in, we have 15 minus 7 to 10. 15 minus 7 is 8, meaning that we would have 4 to 5 is equivalent to 8 to 10. And from there you can see a direct relationship. Multiplying both of them by 2 to create equivalent ratios or a proportion. So 15 is our correct solution. For this next example, you'll notice that the grouping is in the denominator, and that's okay. We're still going to put parentheses around it because this fraction bar line means that there is a group. So we're going to do cross products, showing 4 times the 3. Same thing on the other side, 6 times the group in parentheses n minus 5. And simplify what we can. 4 times 3 is 12. We can't subtract, so we're going to need to distribute. And we can do this right away in that first step. Because they're on opposite sides, they're not affecting each other. So that'll give us 6n minus 30. From there, we're using SADME. So we want to start with any addition or subtraction that's happening away from the variable. So we're going to cancel subtracting 30 by adding 30. That'll cancel out, giving us 42 is equal to 6n, requiring us to divide by 6. 42 divided by 6 is 7. So our final answer is 7 is equal to n. We have one more typical problem before we try this challenge problem. Fraction bar line means that we have a group, so we toss in parentheses and do cross products. 4 times the 6, set equal to 8. We'll put on the outside of the parentheses because of the group, v minus 1. 4 times 6 we can simplify. At the same time that we distribute, giving us 8v minus 8. From there we use SADME to isolate the variable. So we're going to add the 8 to both sides, giving us 32 is equal to 8v. From there we divide by 8, which will give us the answer of 4. So we know that 4 is equal to v, and 4 would have been our missing value. Now let's try this challenge problem. This challenge problem is different because before we only had one variable in each. We had a group, but just one variable. This time, again, we just have one group, the v plus 6, but now we have a variable showing up in different places. This is our variables on both sides. That's why it's an extra challenge problem for you. We're going to multiply diagonally, just like we would have before, showing 8 times v would need to look like 8v. We still need to multiply. 5 times the group would look like this. So now, since there's a variable on both sides, we can't simplify 8v. So the first thing we can simplify is getting rid of the parentheses through distributing. So we'll have 8v is equal to 5 times v plus 30. From here, we have variables on both sides. We want to get variables together by moving the full bundle. It's a positive 5v, and we want it to be with the 8v. Since there's something else here to hold that side, we're going to subtract all 5 of them to the other side. 8v's minus 5 gives us 3 of them left, is equal to 30. From there, it's a one-step equation that we're used to seeing, dividing by 3, and v is equivalent to 10. So 10 would have been our missing value for the variables on both sides of our proportion. And that was our challenge problem. We're using cross products when there's a group there. We want to use cross products when there's a group because that'll create a nice equation that we can solve, whether it's a one-step or a two-step or maybe even a multi-step problem, but using cross products. So multiplying across diagonally.